So this is a system that I was talking about before in the other video. In some systems, we have to multiply both equations in order to get to a coefficient. So there's nothing I can times 3 by that's going to give me 8, and there's nothing I can times 2 by to give me 3. Well, there is actually, but that would involve decimals. And I don't really want to multiply by decimals. I want to multiply by whole numbers. I don't want to get too complicated. So what I'm going to have to do is, step one, I'm going to pick a variable to eliminate. And it might seem random the way I pick them. This time I'm going to pick y to eliminate. But the reason why I want to pick y is because my coefficients are smaller. 8 times 3 is 24, and 3 and 2 is 6. 3 by 2 is 6. So what I want to do here is I'm going to eliminate y. You can totally do this using the x's, there's no shame, and you'll get the exact same answers in the end. So what we're going to do here is we're going to get almost like a common denominator. What number does 2 and 3 divide evenly into? And that's going to be 6. So what do I not need to multiply 3 by to get it to 6? I need to multiply it by 2. And if I'm multiplying this by 2, I have to multiply every term in that equation by 2. All right, so now jumping down to this one, what do I have to multiply 2 by to get it to 6? And so we know we have to multiply it by 3. And if I multiply this by 3, then I have to multiply everything on this side by 3. Okay, so I'm going to do my multiplying. So I have 16x plus 6y equals 26. And then I have 9x plus 6y equals 33. All right, so now I have to decide if I'm adding or subtracting. So again, y is what I'm trying to eliminate. And because they're both positive this time they're both positive, I'm going to go ahead and I'm going to subtract. Because that's the only way I can get rid of them. All right, so we're going to go through and we're going to subtract everything. So 16x subtract 9 is going to give me 7x. And then 6y subtract 6y should give me 0. And then 26 subtract 33. That gives me a negative 7. All right, so now it's just that one-step algebra. 7x equals negative 7, because I don't need to write the 0 in there. It's kind of extra. Want to get x by itself, so there's 7, 7. X is equal to a negative 1. So I've solved for my first variable. Remember, the equation's not complete until you solve for both variables. So we're going to use one of the equations from up here, and again, I like to substitute into the originals. It's muscle memory for me. I do my systems the same way every time, because then it helps me remember. It doesn't matter what equation you put it in, it will work in either one. So I'm going to use that first one. 8x plus 3y equals 13. So 8x plus 3 times negative 1 equals 13. Oh, sorry, I'm off the screen. Minus 3 equals 13. Two-step algebra. So 8x equals 16. X is equal to 2. And I go, oh, geez Louise. What did I do? I substituted, I was doing it like the other equation. And this is what happens when you go too fast. So 8x plus 3y. What was the mistake I made? I substituted the 1 in for y, and it's the variable x. This is what happens when I'm rushing. All right, so I'm going to take that x and I'm going to put it in here. So I'm going to have 8 times negative 1 plus 3y equals 13. So negative 8 plus 3y equals a positive 13. I think I said negative 13. I'm going to add 8 to both sides. 3y equals a positive 21. Divide by 3. Divide by 3. Y equals 7. All right, so there's the answer to number 9.